Right. So we continue with this thing. So we saw triggering, positive edge triggered and negative edge triggered. Then we saw clocked flip flop. Clocked SR flip flop. Audio you have to parane. Audio you have to reply by audio. I can see only the slides. If you are asking something else, did we cover this? I don't remember exactly. Did we cover clocked SR flip flop? Yes, no.
Yes, sir.
Yeah. So this is what asynchronous inputs, preset and clear, right? So sometimes you might be required to just these are the gates, input gating section, and sometimes you might be required to provide say the flip flop in the set state or in the reset state initially itself, or midway when we learn shift registers. You will understand its requirement. Sometimes you might have to reset the shift register in the beginning. Sometimes you might have to set some bits. So all such purposes you need asynchronous input. These are not synchronized to the clock. So if you give a 0 here, this is actually PR complement. The spelling is also wrong. PRESET, preset. It's not trust. So that is PRESET. The text from which I took the figure has spelling mistake. So this is not a correct spelling. Preset. PR bar on. See, active low inputs on. So now you should be aware that is what here it is shown correctly, bubble. So that means active low. You won't give both of them 0 at the same time. That's not a defined condition for SR flip flop. Okay, so the other one giving it is 0 0 to yeah, simultaneously if you preset and clear the flip flop, what happens, that can be a thought of in case of a JK flip flop. That will you can think about that later. Okay, anyway, or you could do it in the lab, give a try. So anyway, this is going to preset the circuit. So you have a 0 here, automatically the NAND gate, any input is 0 means the output is going to be 1 irrespective of whatever is there on the S and R inputs. Same case, if you give a 0 here at the clear input, what happens, the flip flop is reset, that is Q bar becomes high. So Q bar becomes high. So then Q becomes 0. So this is, and if both are 1, the normal operation, it is this flip flop responds to S and R inputs. All cases clock is high, and S and R inputs are asserted only when the clock is high. Okay, so it's asynchronous inputs. So asynchronous inputs come with SR flip flop as well as JK flip flop, both. You will come across ICs like 7473 and 7474. One of them has asynchronous preset and clear, other doesn't have. So 7473 and 7474. I think we discussed, mentioned those ICs yesterday. So then there is JK flip flop. JK flip flop is similar to SR flip flop, except that there is one more feedback provided to this the gating inputs. So gating inputs have a feedback. If you compare these two circuits, so this is going to this place also, right? If you say that is there is a feedback, Q bar is fed to G3, that is the J gating NAND gate, and Q is fed to G4, which is the K gating NAND gate. So that is also there. So explanation is similar. You can explain using the same logic which we used to explain SR. ഏതാണ് ഔട്ട്പുട്ട് ഹൈ ആവുന്നത് അത് നമ്മൾ വെച്ചിട്ടാണ് എക്സ്പ്ലെയിൻ ചെയ്യുന്നത്. Now the truth table shows 0 0. The clock is high. It's a positive edge triggered. This arrow indicates positive edge triggered, right? Or you will be given a diagram like this. You will be given something like this. So you will be given a slope and this. Usually arrow on indicating them. So or else you will be given something positive edge trigger കാണിക്കാൻ വേണ്ടി ഇങ്ങനെ വരയ്ക്കും. Yeah, arrow. So this is an arrow. So ഇങ്ങനെ ഒരു arrow വരച്ചു വെക്കാറുണ്ട്. So So both options are there, right? Anyway, this is a positive edge trigger flip-flop. 0 0 previous state is maintained. Q0 whatever was the initial state, that is maintained. Then 0 1 reset, right? And 1 0 is set, and 1 1 it's toggle. Toggle means if Q was 0 initially, and Q then complementary output Q bar is 1. When you apply 1 1 to this, Q switches to 1 and Q bar switches to 0. That is, it toggles whatever was the initial complement of the previous state will be the output. So this is called as a toggle mode. Now toggle mode has some problems as well as advantages. So we have to see something. Any doubts about this? JK flip-flop? So that we can move to the next topic. Next topic related to JK flip-flop. I am asking in general. Anyone can respond. Not only these people who usually respond. Anyone can respond. Since we means there is no more hour after my hour, no? This is the last hour, no? So I'll take some more time because we started late. We'll complete some more topics. Okay. Class I waited for these people. Right. I thought at least 45 people come, then we start. Okay. So let's toggle mode. I hope you don't have any doubts because none of you are asking doubts about this. Now this is the explanation. You can follow. I mentioned this positive edge triggered on 1 0 set 1 0 ആണെങ്കിൽ set ആയിട്ടായിരിക്കും. Same thing. Now we'll move deal all these flip-flop with a box like this. The logic symbols will be used for this. This is the operation for positive edge triggered flip-flop. Now J equals K equals 1 means toggle state. Q becomes Q bar. Q bar becomes Q. It's toggle. Again, at the next clock, if it is again 1 1 at the inputs, it's again going to toggle. Right. So no change. J equals K equals 0. There is no change in the state of the flip-flop. Right. Now there are some issues like propagation delay. Propagation delay has to do with the say you don't expect the outputs to come just at the same moment as you apply the inputs. There is a finite propagation delay through the logic gates. There is a logic gates through these gates. Actually, we are talking of not one gates, two level of gates are there. We are applying an input, there is a propagation delay in this gate, then there is a propagation delay in this gate, and there is some time. Even if all are in microseconds, there is some finite time for these signals to reach the output and your outputs to be asserted. So that is what we call as the propagation delay. That is the time interval between the application of the triggering edge, that is rising edge in this case, of the clock signal and asynchronous inputs, if it is present and clear, and the time at which the output actually makes transition. That is what we call as propagation delay. Propagation delay depends on the logic gates. And we will see later that the logic gates are made up of transistors and diodes internally. That's why you are learning solid state devices, because even though you see all these pictures and or NOT gates and all those things, internally these are made up of transistors and diodes, MOS devices. So that's what we are discussing in the last module of this subject also, LCD. So we'll discuss more about, there is a spelling mistake here, I typed it wrongly. So we'll discuss more about this flip-flop characters, IC characteristics later on. Propagation delay and all those things, we'll discuss it later. We'll stick on to this because I mentioned this because we need this particular discussion about something which is called as a race around condition. Race around condition in JK flip-flop. Now that happens only in the toggle mode. That race around condition happens only in the toggle mode of the JK flip-flop. That is J equals K equals 1 and the clock is kept high. So here you see J equals 1, K equals 1. and the clock is kept high. So usually expect when the clock is high, Q, if it is 0, then it is going to toggle to high. At the next rising edge, the clock is going to, this is triggering at both the, what do you say, this is a wrong picture to some extent, but you will follow it. We don't really, you will say that it is, I didn't really notice this when I took the picture. It is showing both the rising edge and the trailing edge. So actually the output should go high, and what do you expect? It should remain high until the next clock. That is, I'll draw with this. So the output should go high, and so this is, output goes high and it remains high until the next rising edge of the clock. If you say this is the rising edge, and then again it toggles to low, then it stays low, j equals k equals 1 it again goes high, then it again goes low at this point. So that's what, it's a rising edge triggered ആണ് നമ്മൾ എടുത്തേക്കുന്നത്. ഇവിടെ രണ്ട് ഇതും കാണിച്ചു വെച്ചിട്ടുണ്ട്. Anyway, so just ignore that thing, but that is not relevant to the discussion here. So here we have the situation that if your propagation delay is much smaller than the duration of this clock pulse, propagation delay of the gates is much slower than the duration of this clock pulse, what happens? If you take this case, say j equals 1, k equals 1, and the clock signal is, I'll say clock signal is 1 milliseconds, and the propagation delay of these two gates is 1 nanosecond and 1 nanosecond. So what happens? All these gates, will assume for the simplicity sake 1 nanosecond, nanoseconds, the clock is remaining high for 1 milliseconds. Clock period is 1 millisecond, so 0.5 milliseconds it is remaining high, right? 0.5 milliseconds it is remaining high. What happens in this high duration, in this duration of 0.5 milliseconds where the clock pulse is remaining high, the flip-flop would have toggled several times between Q and Q bar, because the overall propagation delay, this is 1 plus 1, 2 nanoseconds ആവുള്ളൂ ഈ ഒരു ഇൻപുട്ട് ഇവിടെ വരാൻ. പിന്നെ ഒരു 0.5 കൂടി എന്തെങ്കിലും കിട്ടും, but still it is not going to, it's getting enough time to toggle again couple of times. So that is so there will be the final output, you will be uncertain whether it will be 0 or 1. You ideally expected it to remain high. Since it was 0, you thought it would be high, but this is giving to a situation there you have the output is remaining uncertain. There is uncertainty in the output. So this is what we call as a race around condition. So this is what we call as a race around condition in JK flip-flops, right? So so this is the race around condition in JK flip-flop. Any doubts on this? Doubt ഉണ്ടെങ്കിൽ ചോദിക്കണേ. Anyone has a doubt on this? ഉറപ്പായിട്ട് ഇത് ക്വസ്റ്റ്യൻ ഒക്കെ വരാറുള്ളതാണ്, അത് കാരണമാണ് ഞാൻ പ്രത്യേകം ചോദിക്കുന്നത്. ഞാൻ ക്ലാസ്സിലായിരുന്നെങ്കിൽ നിങ്ങളെയൊക്കെ ചീത്ത വിളിക്കേണ്ട സമയം കഴിഞ്ഞു കേട്ടോ. സച്ച് I'm not a robot to teach like this. So it depends on what feedback you give. Even robots require feedback. So hope you understood the idea, right? So ഇതിനെ സോൾവ് ചെയ്യാനുള്ള anyone has a doubt? മണ്ടത്തരമാണെങ്കിൽ ചോദിച്ചോ, കുഴപ്പമൊന്നുമില്ല, ആരും ഒന്നും പറയാൻ പോണില്ല. രഞ്ജന, are you there? Ranjana, hello. Aryan, Aryan as Rajiv, ഈ രഞ്ജന ആര്യൻ ഇന്നലെയും റെസ്പോണ്ട് ചെയ്തില്ല. This Aryan, I have been calling this guy over the past 1 or 2 days and then he doesn't respond. Even Ranjana's case same. Say Harisapna Nair. Did you understand? Could you explain this thing? I'll show this slide. Right, you explain. What is it? It's okay. I'm unable to hear you. That's what. Can you hear me clearly? Can you? Yeah, you can hear me clearly. No എന്ന് ഇവിടെ എല്ലാവരും പറഞ്ഞിട്ടുണ്ട്. നോ എന്ന് പറയുന്നത് എന്താണ്? ഇവിടെ നോ എന്താ പറഞ്ഞത്? നോ സർ പറഞ്ഞേക്കുന്നത് എന്തിനാ? No doubts. Okay, doubts illa. So that's what. Every time I switch to the slides, what happened to Ranjana? This lady is not responding to the doubts. She used to ask some doubts. Alla she. Rabijit Ravindran. I haven't heard this guy. Yeah, I heard it last week. Rabijit. Ruben Thomas, Abby. Doubt and love. Where is Ashish? He wasn't seen for the past 2 days. Class trip, just get a status. What happened to all these people? I don't want lot of messages coming to me. Just tell me a common lie as to some reason. So that's it. So that is the race around condition. You can avoid race around condition by 3 ways. Okay, there are 3 ways to avoid race around condition. You can either keep your clock pulse duration much lesser than the propagation delay. Okay, that can be a possibility. That means you can have very small clock. That's not a very practical solution. You can use edge triggering. That is a very good solution. Usually this happens in the case of pulse triggered. This happens in the case of pulse triggered. So pulse triggered cases ilana koodalum varunathu. Say this is a pulse means level triggered. This level it's triggered on the high condition. That is what clock is high. That's what it's a positive level triggered flip flop. That's the case. So it's level triggered. So I mentioned it as edge triggered when I drew this diagram and all, but it is actually level triggered. Positive level triggered. High condition lana active on clock is remaining high. Right. Anyway, then you can use edge triggering instead of pulse triggering, or else you can go and use something which is called as a master slave JK flip flop. Master slave JK flip flop is variant of this JK flip flop which is used to overcome this problem. So 3 ways to overcome race around condition in JK flip flop. You'll get a master slave JK flip flop IC ആയിട്ട് തന്നെ കിട്ടും. ഇങ്ങനെ ആയിരിക്കും master slave JK flip flop. You will have a master section. This is a JK flip flop, right, and a slave section. This is a slave section. This has 2 gatings. These are the gates. If you see, that is the master section gets the feedback from the Q bar, and this from the Q is fed back to this input, and the clock is the positive. The master section is triggered at the positive rising edge of the clock pulse, and slave section is triggered on the trailing edge. That is, it is inverted and given. So master undergoes transition in the positive edge of the clock, and then what happens? This master outputs are given to the slave. and the clock comes here at the negative edge, which is complemented here. You will get a transition here again, and the output undergoes transition in the full duration of this clock pulse. So this is the thing. So you have the clock pulse, the rising edge, the master circuit gets changed, undergoes transition to whatever is there on the inputs, and at the trailing edge the slave circuit undergoes transition. So what happens? So it is a situation like the master is being followed by the slave, or the slave follows the master. So that's why I call it a master slave JK flip flop circuit. Master slave JK flip flop circuit. MS Dhoni, MS Microsoft. That's what. So you think like that. So this is the master slave JK flip flop. So slave follows the master. So Microsoft Office, MS. So ഇവിടെ ഒരു എം ബാർ എന്നൊക്കെ എഴുതി വെച്ചിട്ടുണ്ടെന്ന് എഴുതാൻ പോകണ്ട കേട്ടോ. Don't write these two things. I searched for several figures, but I couldn't get a very good figure. You don't write this M and M bar. Rest of the things are okay. അനാവശ്യമാണ്. ഇതെന്താണെന്ന് അനാവശ്യമായ ഒരു കൺഫ്യൂഷൻ വരും, എന്താണ് സംഭവം എന്ന്. അതായത് ഔട്ട്പുട്ട് എന്നാ കാണിക്കുന്നത്, മാസ്റ്റർ ഔട്ട്പുട്ടും മാസ്റ്ററിൻ്റെ ഔട്ട്പുട്ടിൻ്റെ കോംപ്ലിമെൻറ്റ്സ് ആണ്. മാസ്റ്റർ ഔട്ട്പുട്ട് എം ആൻഡ് എം ബാർ എസ് ദിസ് ക്യൂ ബാർ എന്ന് പറഞ്ഞ പോലെ മാസ്റ്ററിൻ്റെ കോംപ്ലിമെൻറ്റ് ഔട്ട്പുട്ട്. അത് വളരെ അനാവശ്യ കൺഫ്യൂഷനാണ് ഉണ്ടാക്കുന്നത്. സോ you'll use this notation. We'll use these. This will be the final output. So you'll assume there is a master output. Okay, this is not a standard notation, right? M bar എന്നൊക്കെ പറഞ്ഞാൽ പറഞ്ഞു കഴിഞ്ഞാൽ മനസ്സിലാവില്ല. Done. You drew the figure. Are you drawing the figure? Yes means yes. What is drawing? Right, drawing. Draw. Pen വെച്ച് വരച്ചാൽ മതി. അപ്പോൾ അതൊക്കെ ക്ലാസ്സിലായിരുന്നെങ്കിൽ I could have been more patient. I could see you drawing, and then I am torn between two things: to wind up class on time, save your bandwidth, and also complete the topics. That is, it solves a race around issue. How does it solve the race around issue? In the sense that say you will lock the state in this, once you say j equals 1, k equals 1, okay, erase all ink. I have a condition where j equals 1 and k equals 1, and the clock high state there is a transition, right, and then that is reflected onto the slave in the negative edge of the clock. So in this condition, what happens? Any more changes will not be affected. Any more changes due to j equals k and k equals 1 will not be affecting this, because the slave responds only in the trailing edge of this clock pulse, right? Slave will respond only in the trailing edge, whereas master responds in the leading edge. So here full clock pulse in the duration കഴിഞ്ഞാൽ ഇനി അടുത്തൊരു ഇൻപുട്ടിന് റെസ്പോൺസ് വരുള്ളൂ, അടുത്തൊരു ഇൻപുട്ടിന് എഫക്റ്റ് വരാനുള്ള ഒരു സാധ്യതയുള്ളൂ. നെക്സ്റ്റ് ക്ലോക്ക് പൾസിൽ ഇനി ഒരു ചേഞ്ച് വരാൻ പറ്റുള്ളൂ. സോ ഒരു ക്ലോക്ക് പൾസിൻ്റെ ഡ്യൂറേഷനിൽ തന്നെ വീണ്ടും ട്രാൻസിഷൻ വരില്ല. യു ഹാവ് predictability now. The next transition can occur only in the next clock pulse, leading edge of the next clock pulse, right? That's how it clears. That's how it solves the race around issue. Hope that's clear. Yes, Google. Yes. So that is you don't permit any more changes during the clock cycle. It's locked. The slave has only option to follow the master. it can't the inputs ഇനിയും ഒന്നും കൂടി ടോഗിൾ ചെയ്യണമെന്നുള്ള predictability ആണ്. ഇപ്പോൾ 1-0 ആയിരുന്നെങ്കിൽ 0 ഉണ്ടാവുന്ന ഉറപ്പാണ് at the end of the transition, end of this clock pulse. That's the advantage, right? So let me ask one thing. ഞാൻ ഇവിടെ പടത്തിൽ വരയ്ക്കുന്നതൊക്കെ നിങ്ങൾക്ക് കാണാൻ പറ്റുന്നുണ്ടോ? ഈ പടത്തിൽ I draw something on this figures. Can you? Yes, right. I wanted to make sure that happens. So ഞാൻ എൻ്റെ ഒരു satisfaction. So this is a logic symbol. I thought I am drawing for my own satisfaction. I just wanted to make sure. ഇന്നലെ ഞാൻ ഓർത്ത്. So this is the logic symbol. You have this is shown as bubble because the transition occurs only at the trailing edge of the clock. Bubble വരയ്ക്കണം. Circuit transition നടക്കുന്നത്, final transition occurs at the trailing edge of the clock. Then you have the asynchronous inputs, preset and clear. Then J, K, Q, Q bar. Right. പെട്ടി അങ്ങനെ വരച്ചു വെച്ചോ. MS ധോണി എന്ന് ഓർത്താൽ മതി. I am also a fan of MS Dhoni. He's a good player, really. Inspiring player. Right. So hope you drew the thing. I'll just take one more topic. There is something called as a T flip flop. ഇത് പടം വരച്ചല്ലോ അല്ലേ? T flip flop, JK flip, master slave JK. വെറുതെ വരച്ചാൽ മതി. ക്ലോക്ക് 0, ക്ലോക്ക് ബബിൾ വിട്ടാൽ മതി. ബാക്കിയൊക്കെ അങ്ങനെയൊക്കെ തന്നെ. JK വരയ്ക്കുക, ക്ലോക്ക് വരയ്ക്കുക, പ്രീസെറ്റ് ക്ലിയർ. T ഫ്ലിപ്പ് ഫ്ലോപ്പിൽ ചെയ്തേക്കുന്നത് വെച്ചാൽ SR-ന് ചെയ്യാൻ പറ്റില്ല. SR doesn't have J equals K equals 1 എന്ന് പറഞ്ഞൊരു കണ്ടീഷൻ ഇല്ല. അപ്പോൾ അതുകൊണ്ട് JK ആണ്. JKയുടെ ഇത് ചെയ്യുക. The inputs are tied together. So this is called as a toggle flip flop. This happens in case of the JK flip flop. So what happens? T equals 0 means the output is the previous state. T equals 1 means it's toggling. So this is the logic symbol for T flip flop. T flip flop easy ആയിട്ട് കിട്ടുമെന്ന് എനിക്ക് സംശയമാണ് കേട്ടോ. JK ഉപയോഗിച്ച് തന്നെയാണ് നമ്മൾ T ഫ്ലിപ്പ് ഫ്ലോപ്പ് ഉണ്ടാക്കുന്നത്. Jയും Kയും ടൈ ചെയ്ത് ഹൈയിൽ കൊടുത്തു കഴിഞ്ഞാൽ പിന്നെ ആ T ഫ്ലിപ്പ് ഫ്ലോപ്പായി, ടോഗിൾ ഫ്ലിപ്പ് ഫ്ലോപ്പായി. Jയും Kയും ഹൈ ആക്കിയിട്ട് കഴിഞ്ഞാൽ, ടൈ അപ്പ് ചെയ്തിട്ട് ഹൈ ആക്കിയിട്ട് കഴിഞ്ഞാൽ ടോഗിൾ ഫ്ലിപ്പ് ഫ്ലോപ്പായി. That becomes a toggle flip flop, right? Then finally we have so just draw it. Best finisher. Yeah, I know this lady, she takes snapshots of the phone. ഇങ്ങനെ ഫോൺ സ്ക്രീൻഷോട്ട് എടുക്കാറുണ്ട്, റൈറ്റ്? അമൃത അല്ലേ? A laptop also has a print screen command. I'll anyway share the slides. It's not an issue. ഞാൻ വെയിറ്റ് ചെയ്യാം, but I lost some time. That's in the beginning. That's why I'm hurrying up. I just wanted to complete this topic. Okay. ഇനി ഒരു ഫ്ലിപ്പ് ഫ്ലോപ്പ് കൂടിയുണ്ട്. I just told us a joke കേട്ടോ. So don't take it at heart. So that's so this is toggle flip flop. Then there is a D flip flop, data flip flop. Data flip flop SRO JK ഏതിനോ പറ്റും. ഓറാണ് ഇവിടെ ഈ ടെക്സ്റ്റിനകത്ത്. ഇതെല്ലാം ചില ലെറ്റേഴ്സ് എല്ലാം പോയി. So this is inverted and given to JK or SR, and the difference here is that whatever is happening at the input, that will be reflected in the output. നമ്മൾ പറഞ്ഞായിരുന്നല്ലോ ഡി ഫ്ലിപ്പ് ഫ്ലോപ്പിനെ കുറിച്ച് അല്ലേ? ഡി ലാച്ച്, റൈറ്റ്? ട്രാൻസ്പെറൻറ്റ് ലാച്ച്, സെയിം തിങ്. ഇവിടെ ഫ്ലിപ്പ് ഫ്ലോപ്പാണ്. ക്ലോക്ക് വന്നുകൊണ്ട് അത് ഫ്ലിപ്പ് ഫ്ലോപ്പായി. എഡ്ജ് ട്രിഗറിങ്ങുമാണ് ഉപയോഗിക്കുന്നത്. ഇത് നെഗറ്റീവ് എഡ്ജ് ട്രിഗറിലാണ്. സോ യു ഹാവ് D equals 0 means Q is also going to be 0. D equals 1 means Q is also 1. So this is a D flip flop. D കിട്ടും. D IC ആയിട്ട് തന്നെ വരുന്നുണ്ട്. I think it is 7476 ആണോ? I have to check. I forgot. ഡി ഫ്ലിപ്പ് ഫ്ലോപ്പ്. ഡി ഫ്ലിപ്പ് ഫ്ലോപ്പിന് ലാബിലുണ്ട്. ലാബിൽ ഡി ഫ്ലിപ്പ് ഫ്ലോപ്പിൻ്റെ IC ഒക്കെ ഉണ്ട്. എല്ലാവരും ഇരിപ്പുണ്ട് എപ്പോഴും. ശ്രീകുമാറാണ്. ശ്രീകുമാർ പൊക്കം കുറഞ്ഞൊരു ലാബ് സ്റ്റാഫില്ലേ, ശ്രീകുമാറിന് സനോജൊക്കെയാണ് നിങ്ങളുടെ ഇത്. നമ്മുടെ ഒരു ടെക്നിക്കൽ സ്റ്റാഫിൻ്റെ സനീഷ് എന്ന് പറയുന്ന ലാബ് സ്റ്റാഫിൻ്റെ ഫാദർ മരിച്ചുപോയി ഇന്നലെ. യെസ്റ്റർഡേ നൈറ്റ് ലാബ് സ്റ്റാഫിൻ്റെ ഫാദർ മരിച്ചുപോയി. അധികം ആയിട്ടില്ല സനീഷ് സർവീസ് ജോയിൻ ചെയ്തിട്ട്, 2 years ആവുന്നുള്ളൂ. റൈറ്റ്. സോ ഇനിയുള്ള ടോപ്പിക്ക് നമ്മൾ നാളെ പഠിക്കും. എക്സൈറ്റേഷൻ ടേബിൾ. ദാറ്റ് ഈസ് റിക്വയറിങ് സം ടൈം ഫോർ മീ ടു എക്സ്പ്ലെയിൻ. ഇനിയുള്ള നമുക്ക് കുറച്ച് എക്സ്പ്ലനേഷനൊക്കെയാണ്. ഇത് ഇങ്ങനെ കുറേ പരിപാടികളൊക്കെ ഉണ്ട്. ഡിസൈനിലേക്കൊക്കെ നമ്മൾ പോവാണ്. ക്യാരക്ടറിസ്റ്റിക് ഇക്വേഷൻ, കൺവേർഷൻ ഓഫ് ഫ്ലിപ്പ് ഫ്ലോപ്സ്, അങ്ങനെ പല പരിപാടികളൊക്കെയാണ് ഇനി കിടക്കുന്നു. അപ്പോൾ ദാറ്റ് വിൽ ടേക്ക് അപ്പ് നെക്സ്റ്റ് ഡേ. സോ